How are you, my friends? This is Calculus 1 solved questions, finding higher derivatives. Also, we will see some implicit differentiation questions. And this is part 2. Please, you can go and check part 1, finding higher derivatives. Question number 1, find the second derivative, y double prime, of the function that is defined implicitly by the equation x squared minus xy plus y squared is equal to 9. So we use implicit differentiation here, and we start by finding the first derivative. So the derivative on the left side will be d over dx of x squared minus xy plus y squared. On the right side, d over dx of 9, which is 0. So the derivative of x squared will be 2x, and here we have xy. So that's a product. So it will be u prime v plus v prime u minus the derivative of the x is 1, so minus y. And then y prime, this is the derivative of y minus xy prime, plus the derivative of y squared, 2y times y prime is equal to 0. So let's take y prime as a common factor here. Inside we will have 2y minus x. Move this 2x minus y on the other side, becomes y minus 2x. So y prime will be y minus 2x divided by 2y minus x. Y prime is the same as dy over dx. Let's continue on the next slide to find the second derivative. From the last slide, this is y prime, and this is the given equation. Let's find the second derivative. Here we have to use the quotient rule on y prime. So the second derivative will be u prime v minus v prime u divided by v squared. This is lecture number 7 in Calculus 1. You can check that if you like. So y minus 2x prime times 2y minus x minus, from the formula here, 2y minus x all prime times y minus 2x over v squared, which is 2y minus x all squared. The derivative now, y prime minus 2 times this minus 2y prime minus 1 times y minus 2x divided by 2y minus x all squared. So let's multiply here by FOIL method, y prime times 2y, y prime times x, etc. You can continue minus 4y plus 2x. Same here, you have to take care of the signs. You simplify, you get 3xy prime minus 3y. Please check it, divided by 2y minus x all squared. Now, this is the second derivative. What do we have to do? Take this part here, y prime, from the last slide, y prime will be y minus 2x over 2y minus x, and we have to replace it there. See this part, we have to multiply it by 3x. So you can try that yourself, please, if you like, and then check it on the next slide. So from the last slide, we have the second derivative, 3xy prime minus 3y divided by 2y minus x all squared. Also, we had y prime, the first derivative, y minus 2x over 2y minus x. So I replace y prime here in the numerator. See, I multiply that by 3x. 3x divided by 1. So 3x times the y, 3xy, 3x times the minus 2x will be minus 6x squared. And here we have to find the LCD. See, this is a fraction minus 3y. So the LCD will be 2y minus x. So I multiply minus 3y times 2y minus 6y squared. Minus 3y times minus x will be plus 3xy. Now when I add here, I get minus 6x squared plus 6xy minus 6y squared. So easily I can take minus 6 as a common factor. And here I multiply by the reciprocal. See, this is 2y minus x squared over 1. So I multiply the first fraction by 1 over that. So there will be cube here, 2y minus x all cubed. When I take minus 6 as a common factor, it will be x squared minus xy plus y squared. And I remember the given equation was x squared minus xy plus y squared. So I can replace all that by 9. Now the second derivative will be minus 6 times 9 minus 54 divided by 2y minus x all cubed. This is a really heavy question. Question number 2 is a nice question. Same idea. Find the second derivative y double prime of this, of the function y that's defined explicitly. Sine of y is equal xy. So we have to use implicit differentiation. So the derivative of sine of y is equal to the derivative of xy. On the left side here, we can use chain rule. On the right side, we can use the product rule. So this will be the derivative of sine of y will be cosine of y, y prime. Here we have u prime v plus v prime u. The derivative of the x will be 1 times the y plus y prime times the x. Okay, so I put all the terms with y prime on one side, and then I leave y on the other side. So I can take y prime as a common factor. So y prime, which is dy over dx, will be y divided by cosine of y minus x. This is the first derivative. You can try the second derivative by yourself if you like, before you see the answer. Now let's find the second derivative. We have here quotient, so we have to use a quotient rule. So it will be y prime times cosine of y minus x minus the derivative of cosine of y minus x times the y over cosine of y minus x all squared. Using this formula, u prime v minus v prime u divided by v squared from lecture number 7. So this is y prime, and then here the derivative will be cosine of y will be minus sine of y times y prime minus the derivative of the x will be 1. Simplifying the numerator here, y prime cosine of y minus y prime x plus y prime, see there's a minus and minus, y prime times the y times sine of y. And then we have minus, with this minus becomes plus. Just be careful there, plus y. So I take y prime as a common factor, cosine of y minus x plus y sine of y, and then I have a plus y by itself at the end, divided by cosine of y minus x all squared. So I have to get y prime and replace it here. So y prime is y divided by cosine of y minus x times all this, cosine of y minus x plus y sine of y, and there is, after the bracket, we have plus y. Okay, now we have cosine of y minus x. This is the denominator here, same as this cosine of y minus x squared. So we multiply by the reciprocal 1 over this. It will be cosine of y minus x cubed. And then remember here to multiply cosine of y minus x times this y, because we are adding the fractions. So the LCD is cosine of y minus x. You multiply that by this y here. And now this y also multiplied by this. So we can take a y as a common factor. And then inside we have cosine of y will be 2 cosine of y minus x will be minus 2x plus y sine of y. So the second derivative will be y times all this bracket divided by cosine of y minus x all cubed. This is an easy question. We have f of t is equal 5 plus 6 sine 3t. Let's find the 21st derivative of f at pi over 3. So first, we start by finding the first derivative, f prime of t. The derivative of 5 will be 0. So this is 6, the coefficient. Sine of 3t will be 3 cosine of 3t. This is the first derivative. The second derivative will be, this is a constant, 6 times the 3. The derivative of cosine of 3t will be minus sine of 3t, and there is a 3, so it becomes 3 squared. So I will go here by this pattern. The third derivative, the fourth derivative, the fifth derivative, the sixth derivative. Now there is an even and odd here. So if I go, the fifth derivative will be 6 times 3 to the power 5 cosine of 3t. I need the 21st derivative of the function of t. So it will be 6 times 3 to the power 21 times cosine of 3t. So I have to replace now in this derivative pi over 3 for the t. So it becomes 3 to the power 21 times the 6 at the beginning times cosine of 3, and t is pi over 3. So I cancel the 3 here. Cosine of pi will be minus 1. So the final answer will be minus 6 times 3 to the power 21. Question number 4, we have y equals sine of 2x minus cosine of 2x. Let's find the fourth derivative of y at 0. So we find the first derivative, the second, the third, and then the fourth. Then we replace x by 0. So the first derivative y prime will be 2 cosine of 2x, the derivative of sine of 2x. Cosine of 2x, the derivative will be minus sine of 2x. There's a minus here, it becomes plus 2 sine of 2x. Now we go for the second derivative, third derivative, and the fourth derivative will be 16 sine of 2x minus 16 cosine of 2x. This is the fourth derivative. I replace x by 0, so it will be 16 sine of 0 minus 16 cosine of the 0. Sine of the 0 is 0, cosine of the 0 is 1. So the fourth derivative of y at 0 will be minus 16. Question number 5 is a nice question here. We have f of 2 is equal to 10. F prime of x is equal to x squared times f of x for all values of x. Let's find the second derivative of the function f at 2. So let's find the second derivative from the first. The first derivative is given. The function f is not given. So the second derivative of the function, we can use the product rule because we have x squared times the function itself. So the derivative of the x squared will be 2x times the function plus x squared times f prime of the function f. Let's replace x equals 2 in the last equation here. So what do we need? F double prime at 2. It will be 2. See, this is the coefficient. X equals 2 also. F of 2 plus x squared means 2 squared times f prime at 2. Now on the right side here, I would like to show you how to find f prime at 2. So I take this given equation. F prime at 2 will be 2 squared times f of 2. F of 2 is given here is 10. So 4 times 10 will be 40. So f prime of 2 is 40, and this is 4, and this is 2 times 2 is 4. F of 2 also is 10. So 40 plus 160, f double prime at 2 is 200. For more questions on higher derivatives, you can see the lectures 13 and 19 in the Calculus 1 lectures. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.